Please don't repeat that. It is easily the most controversial thing that I've ever said in my entire teaching career. Cool. All right, so today what's up?
There was just one video on the trip where you said that, and I tried to go back to the other, video.
Good.
To see what you were trying to talk
I'm glad to hear it. I've never said a controversial thing in my life. Okay. All right. So, for this, what we're going to do today, we're going to have a lot of chill time. We might jump into the next stuff like a continuation, but I'm totally cool with giving you guys some time for the homework if needed. But what we're starting to see is, I think we pointed this out the other day, we've really been using the chain rule all along. So with every single thing that we did, x squared, we don't use a chain rule, it's just 2x, right? But it really is a chain rule, because if we write x squared, and this is just to build this up, just so we can see something happens, you do not need to write this one. If I said, let's take the derivative of x squared, do you guys use the chain rule? I bet you do, and you're not even aware of it. If we wanted to treat it like a chain rule, what is the inside? This is like the inside, and the outer piece is x squared, right? So let's try the chain rule real quick, and I'm going to convince you that you have been doing it. You just haven't really had to use anything too crazy. Help me differentiate with the chain rule. The outside function is x squared. What happens? A 2 goes here. We don't touch it, and there's a 1 here. We don't normally write it, but there is a 1. And then we multiply by the derivative of the inside. What's the derivative of the inside? Do we get 2x still? You've been doing the chain rule. Just every single chain rule up until this point has been a derivative of 1 here. So it's worked out nicely every time. What we have instead is a new way to define these rules in a much more generalized sense. If you have all of your derivatives right now that we've had memorized, we still have them, but we're just going to change the way that they look. So here we go. We're going to rewrite some rules. And I'm going to switch to this color. Rewrite. And I'm going to say derivative rules, and I'm just going to use d dx rules. Okay. For these, we're not going to do every single one of them, and this is going to look strange if we don't preface this. So we're going to say let u be a function of x. Now, we can say a function of x. More specifically, I'm going to write it more clearly. Let u be a function in terms of x. And this language has shown up essentially in every math class you've ever taken. I don't remember if we went through it. This throws people for a loop for some reason. All this means is that my function is called u, and what's the variable that I'm going to use in this function? X. So we didn't write it, but this could be u of x. And it means the same thing. It's just telling me this is a variable that we use. Okay, so before we did a bunch of derivatives, and we're just going to do a couple of them right now, just to see that the chain rule really is here. So if we're looking at, and I'll switch color for every single one of these, we know the derivative of sine, I think, of sine x. Now in this case, I'm just going to write sine u. Now this little change, it doesn't really feel that crazy because you're going to be tempted possibly to just say it's cosine u. Okay, reasonable to think that, but notice, here's the derivative with respect to x. I'm trying to take that for a sine function whose argument is a u instead. Now, what is not clear entirely, I mean it is, but you might overlook it, is this a function of its own? So this could be like 2x plus 3 or something like that, which means there really is an x in here, we just have to deal with it through the chain rule because there's a distinct inside and outside piece. So as we look at this, the derivative with respect to x, what's the outside piece here? Sine, and the inside is u. So what's the derivative of the outside? Cosine. What do we do with the inside when we're using chain rule? Nothing. Don't touch it. U. And then we do one more little thing. Times the derivative of the inside. Now, I don't really mind how you write it. I'm going to write it as u prime with the understanding that it's really this, du dx. That's the same thing. I don't love this notation 90% of the time. Instead of du dx, what am I going to write? U prime. And I'm fine with that if you guys are fine with it. Okay. We can see this happen on rule after rule after rule that we've seen. If we take d dx, for example, of the cosine of u, And I changed the order here, but I'm not backtracking now. What's the outside piece? Cosine, whose derivative is negative sine. What is the argument of my sine? U. And what must I multiply by? U prime. And we get the same rules. We just have to make sure that we tack on that U on the outside. In reality, this has been the rule all along. It's just always been x, and the derivative was always 1. Okay, one more that I'm going to write, and then I'm going to challenge you guys to write the other 3 here from memory first, but you might have to check. Tangent of U. What is the derivative of tangent? So tangent is defined as sine over cosine, and you could do a big gross quotient rule if you wanted, or you can check your notes, or you can shout it out if you know it. So is it a cofunction, or is it just a regular function? Regular, so there's no negative. Secant squared U times what? U prime. Okay, I'm going to give us an option here. I think you should have the other 3. I'm not going to give us an option. I lied. I want you to do the other 3 trig functions for me. Now, notice I changed the order a little bit. Normally, we do sine, tangent, and secant. If you look back in your notes, that's how they're arranged. I don't care the order that you put them in, but I'm going to do them, I don't know, sine. That seems to match with a cosecant in my brain. Cosecant of U. I want you to write down the derivative with respect to x of, we already did sine, so we better do secant of U. And I want you to do the same thing for the cotangent of U. Cool. I'm going to give you guys a second. I would encourage, try them from memory. Write very lightly so that if you have to change them, you can. But let's see if we can remember these other 3 derivatives and just make that little extension to the chain rule. I'll give us a moment. Like full disclosure, I might be wrong because I'm trying very hard not to look at these. And it's been several years since I've done it too. So I wouldn't say I'm learning right now, but I'm trying to recall everything. Cosecant, I know it's negative. Why? Because it's a cofunction. Now, I think it's going to be cosecant x, cotangent x, is what I think it's going to be. Okay. That's right. Now, it's not x, though. It's cosecant u, cotangent u, times one more thing. U prime. We have to take the derivative of the inside. Secant is just the positive version of this, but without a cosecant and a cotangent. It becomes, I believe, secant u, tangent u. And don't just blindly trust me. Like, again, I'm going from memory. Is this right? Times u prime. And then this one, again, a co-function. I know there's going to be a negative, and I believe it's cosecant squared. Cosecant squared of u. Anything I should multiply by? U prime. Now, looking at this, there's one more rule that we can really, really easily address here. And you'll probably forever associate it with that silly picture, would be my guess. And I'm cool with that. I want to add one more. It doesn't fit in this trig one. What if I wanted the derivative with respect to x of something of the form e to the u? One more little piece. U prime. E to the u times u prime. It works the exact same as e to the x. It just happens not to have a 1 as a derivative. Now, with problems like this, there's a lot of really cool variations that we can knock out here. So we're going to do 2 problems right now, and then I'm going to give you time to work on the assignment. If we wind up using all of it, so be it. But if people get through or we're ready to move on, I'm cool to move forward as well. Okay, so 2 good examples. Let's knock them out. Questions, more time, anything here first? Okay. The really cool one? All right. Here we go. I don't have any directions. I'm just going to give one problem like this type. Here's what I know. I'm given a function, h, and I'm told that this is equal to f composed with g. Deal. That's it. H is equal to f composed with g. Beyond this, though, we do get a little bit more. I want us to find h prime of negative 1 given, and I'm going to write this not in like a line of text so it's a little bit easier to pick apart, but your book and AP test I think do it in a line of text, just so you're aware. Here's what I know. G of negative 1 is equal to 2. And I know that G prime of negative 1 is negative 3. I know that F of 2, sorry, what? No, I'm all goofed up. Nope, I'm okay. F of 2 equals negative 2. And that F prime, we're going to switch that. F prime of 2 is 2. Negative 2, I'm sorry. And F of 2 equals 4. That was my initial thought, but then we'll see. Gut feeling, yes. Real answer, no. And we'll see why here in a second. Okay. This feels like a very different type of problem. Very, like, one, we're obviously doing calculus, right? Because I see h prime. But it just feels different because I don't get a function. We have to think about this. Now, as I'm looking at this, we have every tool necessary. There's nothing new about this problem. It's just new the way it's presented, and it feels different. I want you guys to help me with this. I'm going to go with whatever direction you guys suggest, and if we wind up going down a rabbit hole that doesn't lead to anything, oh well, we'll respond. All right. What's up? I don't know what to do. Talk it out. Give me suggestions. You can shout them out. We're going to try this a different way. For 60 seconds, I want you to try to come up with a plan of attack with your neighbors, and then we'll come back together and we'll have shout out answers so we don't just wait here awkwardly. Cool. Something that we can do. Instead of saying, can we rewrite this to make more sense, can we rewrite this more formally than it was given? It's probably not just h. I assume it's h of, doesn't matter the variable, but I'm okay with x. So if we try to rewrite it just to see if we can make sense of it, h of x is a more formal version of this, and this would be f of, so we'll get there. You're correct, whoever said that. But do you guys agree that this is like the true first step? This is much more formalized. Now, this notation is not super duper helpful for us in this context because we probably all remember chain rule in about the same way. If only there were a way that I could rewrite what it means to take f of x and compose it with g of x. H of x is f of g of x. Now, this is all notation stuff. But we haven't really changed anything. We've just made it more clear. As soon as we write this, this problem, I hope, becomes much more accessible. And you may not agree with that quite yet, but we're going to see that it does indeed get easier. If I wanted to take h prime of x, and I don't have anything written here, what do I take the derivative of? So I take f prime. What do I do with the inside? Leave it, right? We don't change it. It's still what then? G of x. And then we take whatever this is and we multiply it by g prime of x. This is, I think, and I hope, probably about exactly what is written either on the previous page or directly above this in your notes when we defined the chain rule. If you don't see that, verify for me that if you look at when we first wrote the chain rule in our notes, we probably have an expression that looks very similar to this. Now, we're trying to find h prime of what? So I'm going to work this way just to save space. We're trying to find h prime of negative 1. What did I just replace x with? Okay, so I've done it on the left side. Could I do it on the right side as well? This is f prime of g of what? It's just negative 1, right? Anywhere there's an x, we're replacing it. Times g prime of, I hear murmuring, and I'm just assuming that you're all telling me negative 1 over and over because it's the same answer each time. Maybe not the best use of questioning on my part. Strive to be better. Cool. I will not remember, just for the record. Also, my coffee is very loud today. Well, I'm stuck. Gosh, I don't know what any of these things are. Dang it, if only I knew what g of negative 1 was. Oh my gosh, it's 2. Oh, okay. This is f prime of 2, and here's, Rafa, where I also had the same hiccup in my brain and why it works. Gosh dang it, what's g prime of -1? Oh, hey, it's -3. Neat. All right, well, now I have a whole new problem. Gosh darn it. What is f prime of 2? Oh my gosh, I have that also. Wow, this thing's just working out fantastically. What is h prime of -1 then? Are you sure? I like that answer much more. And look at that, we're done. We have taken what seems like a crazy hard problem that we can't make sense of, and just by simply saying, look at this is what it is. I'm going to ask the question again, and maybe if you said yes just because you wanted, like you thought I wanted a yes, don't do that in the future. If I say this is a hard problem and you disagree, say no, I'm cool with it. Is this really a hard problem anymore though? As long as you know the chain rule and you can say that this is this, and you can put the pieces here, this problem is one that you hope to see on an AP exam. There's no real thought needed except plug and check. Okay, in contrast with this, before we move on, questions here. All right, so one more. I'm going to pause this because I want you guys to do it. It is another chain rule related problem. This was very much chain rule here. Last one. Again, it's just a single example. I want you to find the equation of, do you want a tangent or a normal line? Okay. Find the equation of tangent line to the graph of y equals the square root of 2x plus 1 when x equals 4. Okay, my first little thing, and if you want an asterisk over here, I'm not going to do anything specific to this problem, but I would really like to make sense of this. Root a is root awful. However, a to some power is much nicer to deal with. That's the same as a to what power? 1/2. This property will make this problem much easier. Cool. I will have you guys do it to it. We'll meet back up in a second, and I'll come walk around to answer questions or awkwardly wander as you guys work. Cool. See you in a minute. As I go through this, we have immediately my first strong suggestion. If you do this without changing to an exponent, I don't know that I'll be able to follow it, like legitimately. You should change stuff to exponents. They work so much nicer 100% of the time. So immediately, the very first thing that I would do is I'm going to rewrite this. And there's two reasons to do this. And I guess they're kind of the same, but there's two justifications in my use. On this one right here with the square root, I can clearly identify the inside piece as 2x plus 1, and maybe I think you might be able to identify that the outside piece is the square root of u, or whatever it is. Okay, that's okay, but we don't have a rule that directly says the derivative of a square root. Now, we really do because square roots are just 1/2 powers, and it's just a power rule with this, and it works super nicely. It is so much easier to see that we're going to use the power rule if we have a power to talk about. So, clear inside and outside pieces. What is the inside? 2x plus 1. Now, if we do this, and I would never like physically write this down or write a u equals anything, because we'll do this later in the year, but this is essentially my u piece, right? The inside, which means the outside piece is just u to the 1/2, or the square root. So let's just differentiate this as normal. I'll take the derivative of the left side of the equation, and we've never presented it this way, but I just want to show you guys it's the same as everything. If I take the derivative of the left, I should also take the derivative of the right. We're really truly just using properties of equality. Just like if I add something to both sides, we're just taking the derivative of both sides. So I did the left, here it is, and you guys did the right, and it's what? 1/2 2x plus 1. What's my new power? The negative 1/2, because we just subtract 1 from it. And then we multiply this by the inside's derivative. 2. Something super convenient happens here. Chapa, dig on, right? Or dewon, if you'd rather. And now let's keep kicking. What's left in the numerator? In just the numerator, it's just a 1. Now, if you answer the 2x plus 1 to the negative 1/2, you're not wrong, but a negative exponent just switches, right? If it's in the numerator, it goes to the denominator or vice versa. At this point, I don't have any issue because the only reason that I changed this is to make the derivative easy. You can keep it to the 1/2 power if you'd rather. It's natural for me, once I'm not doing a derivative anymore, to do this. If you don't like this, that's fine. You can simply do this instead. I prefer this one. I don't know why. Purely out of curiosity, they're both equally good and work well. Which one do you prefer, A or B? A? Maybe, okay, yeah, it's purely opinion there, right? Okay, are we done? No, we have only found the derivative. And what's the point of the derivative? The slope of my tangent line. So, we're trying to find y prime of 4. That's my slope. So y prime of 4. And I'm just going to say here it is my slope that I'm after, just to reemphasize that. This is 1 over the square root of 9 is what it simplifies to be. We all get 1/3. Cool. Anything else that I should do? I have a slope. I need an equation. What else do I need if I have a slope? I need a point. Well, unfortunately, I don't have a point. I have half a point. But do I really have a point? When x is 4, and I'm going to switch color here, we need our point. From here, I can reason out that if x is 4, I can get the value of y by plugging it in. What's 2 times 4? Plus 1? And the square root of that. Hey, my point is 4, 3. I now have a slope, and I have a point. Do I have everything I need for the equation? Bet, bruh. Cool. Let's check it. Go ahead. How did I get 4, 3? Because I know that it's tangent to this graph, right? So if I want to know what point does it run through, and they tell me when x is 4, when I find y of 4, I get 3, and this is just 4, 3. Yep, back into the original. So this is the original, and we'll be really clear, original point on y. And then in parentheses, if you want it, this is where people get goofed up. It's not on y prime. This is the point on y. We only use y prime to get the slope. Okay, so do we have to get it to y equals mx plus b? No. Should we bother getting it into y equals mx plus b if all we're asked to do is find the equation? No. Y minus 3 equals, what was the slope I needed? 1/3 x minus 4. This is my tangent line. If I wanted the normal line, only one change needs to happen. This is -3 instead of 1/3. It's the opposite reciprocal. Okay. Chain rule stuff. We are knocking on the door of some pretty cool problems. I can't wait until we start getting our sweet word problems coming up. For now, I want you guys to use the last 12 minutes to continue working on the assignment from yesterday. Cool. I'm not going to add anything to the homework tonight, but there is an additional homework that I offered you, right? What is it? Go to band or make a poster for school spirit stuff.